You are listening to the Break Time Tech Talks podcast, a bite-sized tech podcast for busy developers, where we'll briefly cover technical topics, news snippets, and more in short time blocks. I'm your host, Jennifer Reif, an avid developer and problem solver with special interest in data, learning, and all things technology. Happy Valentine's Day to everyone. This week, I've been prepping very hard for the DevNexus conference coming up at the beginning of March, but I've also had a little bit of time to do a few other things too. I have some random thoughts about general items this week, and then I watched a fascinating recording of Grace Hopper's lecture on data, hardware, and software. The three general topics I want to touch on this week are structure, iterate, and learn. And all three of these things came up throughout the week as I was prepping different things and focusing in on some different things, and I'll talk a little bit about each one of those. But the first one of structure is I was working on the DevNexus keynote and have just refreshed my memory on the importance of outlines for structuring your thoughts. And this is something most of us probably learn in school when you go to write something, whether that's an email or a report or a paper or something. They always tell you to outline your thoughts and create bullet points of high-level concepts that you want to cover. One, so that you make sure you cover everything you want to, and two, so that the story flows from one piece to the other. And I've never really noticed myself, I do this kind of naturally when I write my previous presentations, but I find that I often let the code dictate my outline. So I'll have a piece of code and things that I want to cover there. And then I just add slides and content that fit and provide background leading into that code or that demo. I often find this is the way that I put together presentations and just kind of center it around the code and then add structured thoughts around that. And that's not the way I've ended up needing to approach this type of presentation for DevNexus. I've ended up putting down some thoughts, random thoughts in slides and organizing them there and finding out that doesn't really work and I'm kind of losing my train of thought. So that's when I opened up a doc and just started hacking at some things and writing notes and outlines and things. And I've actually written outlines, scratched them and rewritten and all sorts of things. We're coming together now, but it's just been a little bit more intensive process than what I anticipated initially. It's really reinforcing the importance of structuring those thoughts out via outlining concepts. But I also use this in blogging, and I made that connection earlier today where when I write down technical blogs, I'll develop my piece of code, sure, but when I go to write the technical blog, I often will outline via headers, and I'll just put in, oh, this is the section I'm going to cover, this section. Again, I let the code dictate the order of things. This needs to go first, next, here's what I add here, and kind of compile on those next features or things that I need to add to the code. But I also go back and I structure my writing too, and I'll fill in those headers and then maybe write a couple of comments in the document for what I want this thing to say. And then I go back and actually do the writing at a later point in time. I already do this in my blogging. I just have never really applied it to an entire presentation recently. And so I'm working on that for this week. And again, exciting the things that are coming together, but it was something that I had to play with and work at for a little bit this week. We also do this in coding and architecture too. When we put together an application or even just architecture for processing data or passing information around to different systems and so on. When we architect systems, when we code applications, we are constructing via an outline. We need this component to handle this task, this component to handle this task, and they need to be able to talk to one another in this way. That was just outlining and structuring thoughts in general and the different ways that we go about that. The next piece was iterate. We already do this a lot with coding anyway, right? We start with something and that needs improved, or we could make the code more efficient, or we could optimize it, or we could do better at testing or adding documentation or so on. And I went back this week and looked at Neo4j's Graph Academy Java course for working with Neo4j and Java, and just reviewed that, the positives, the negatives, the content that's there and such, and got my wheels turning on the frameworks that are being used, how sometimes we might over-engineer certain concepts or maybe even not explain things super well. That's something I'm going to go back and iterate on a little bit and try to improve that and make it easier for somebody coming in to learn that material as well. So that was something that was on my mind this week, and just one of the things that hopefully you can be looking for some changes coming in the next several weeks, something like that. The final thing that I worked on this week and learned was just in general learning. If you've been around my content, at all, even podcasting or blogging or even just technical presenting, you probably have figured out that I like to learn a lot and constantly, right? Sometimes not so much. You don't want it to be overwhelming, but I do enjoy learning. And the last few years, I've really enjoyed adding some technical reads or historical reads to my list of things that I like to do on the side outside of kind of my daily work. And when I was in school, I did a lot of technical reading for school. This is required. You have to read so many pages in order to study for the exam or to know this information for class or so on. And so a lot of that reading wasn't as much fun. I didn't do a whole lot of extracurricular reading while I was in school. But recently, in the last, I'd say 2 to 3 years, I've gotten back into the habit of just really thriving on books and stories. And one of the most recent reads that I'm working through right now that is opening my eyes to some of the historical and professional things about technology is a book called The Woman Who Smashed Codes by Jason Fagone. And it's a story about, mostly focused around Elizabeth Friedman, but by relation, her husband, William, as well. And this was a pair of people who broke ciphers. They were really into cryptology and how her career started, the things that she worked on. She started out on a historical, almost conspiracy project, if you will, and then moved into military ciphers during the World Wars. And then I haven't gotten to this point yet, but it's starting to hint at her work maybe in some radio or technical codes as well that are coming here later. Really interesting how that's tying into technology and some of the history there that feeds into modern day cryptology and hashes and ciphers that, of course, we use in the technology world as well. It's also interesting because I pulled up the piece of content that I'm going to talk about in just a couple of minutes, and Grace Hopper is actually speaking in the William Friedman room, which actually was named after Elizabeth Friedman's husband, who, again, was one of the introductory couples in cryptology and wrote a lot of content around hashes and codes. So again, just as you learn some of these things, the more you read, the more things you start tying together and things start making sense. And it's all this added context you didn't know was there before. You end up starting, here I go back to my kind of data graph nerdiness, but these data points that you pick up over time as you learn more and more things start to become a graph. They start to become connected context to different things that you already know or have already learned. And then that data turns into information that then can get even more depth of meaning, and you can apply in other ways and use those constructs elsewhere. The content piece I wanted to talk about that I've already hinted about now is that we can now watch Grace Hopper's famed 1982 lecture on YouTube. And I'll link the article in the show notes. It's a fabulous set of videos. It's 2 videos, one whole lecture broken into 2. Initially, this was a lecture to NSA employees in 1982. It was recorded on a very old technology, so it couldn't be digitized and released to the public until relatively recently. This article that I'm looking at was from late last summer. And her session, Grace Hopper's session, was on data, hardware, and software. And it's interesting because the presentation was given and recorded in 1982. But some of the things that she talks about, we are still battling and still working on to this day. Now, of course, we're in different stages and we're different places and different challenges now, but some of the same general overarching concepts are still present. It's just interesting to hear her thoughts and her mind on this. One thing that I really noticed just out of the gate was she didn't use a whole lot of aids or notes or anything like that. She may have had a piece of paper that she was monitoring where she was in her dialogue, but she told stories off the cuff. She was interesting. She was entertaining. She had a complete thought process. Again, going back to that outlining that we were talking about earlier, her story arc made perfect sense. Things tied back into earlier concepts that she talked about. It was just a really fascinating, fantastically done presentation with some really good nuggets of information and helpful content. Her presentation was on data, hardware, and software. And again, realize this is 1982, so you'll have to set the stage just a bit. But the data piece that she started off with, I thought was super interesting. Again, going back to my data nerd side here, she talks a lot about the value of information. And we don't often quantify what is the value of the information that we're dealing with. Are certain pieces of information more valuable than others? And that data supports everything else that we do technically. It is the input and output. It is the flow, the thing that we need to move around. It's the expensive, highly valuable thing. You see people and companies open sourcing and outsourcing code, but they often will privatize their data because that's the valuable piece. And she also talks about how difficult it is and how important it is to protect the information and find those valuable bits of information and try to protect that information in whatever way possible. And she talks a lot about how that was a challenge and something that we're not doing enough of. And of course, that's still a conversation we're having today. Protecting information, how valuable is it? We're not doing enough to really protect and truly keep our data entrusted to whatever entity we're leading it out to, right? And then she also talks a little bit about the cost, not only of doing something, but then the cost of not doing it. So we don't often evaluate. We always look at, what's it going to cost us to do this thing or to upgrade to this thing? But we don't often look at and calculate the cost of not doing it. What money are we, not even money, but what resources are we losing out on by not going to this thing or not doing X? And this is a theme that kind of comes up all throughout her other stories and concepts throughout the presentation. This is not just one thing she relates to a particular piece and leaves it, but she talks later again about the cost of not doing something. You need to make those calculations and figure out what is the best and most efficient choice here. She also goes into a little bit of detail on hardware. She talks about the speed of hardware and the limitations there. And those are much different now, of course. So we've solved a lot of problems with hardware and increased the improvements to hardware calculations and different limitations now, but we're still problem solving with hardware. We look at the AI spectrum and do we have the resources and the compute and the time and the money in order to run these intense computations. And so we're still running up against some of these things, just in much different spheres now. And then her last component is talking about software. And she starts working on going to a system of computers, which is, of course, something that we do. We have networks and computers that talk to one another and so on. And she also talks about software and modules and how you don't just build in kind of these monoliths, but you'll need to have individual independent components and things like kind of microservices come into play, or these small kind of functional type of concepts. And of course, this is all stuff we balance and do some on a day-to-day basis. And I just find it really interesting to look at the historical context and the things that we're doing today, either in line with some of those things she's talking about or how we do them differently because of certain other things. On this Valentine's Day, I'm wishing you hearts and happiness in whatever flavor suits you. If you can think of one thing in technology that you enjoy or even love, then hopefully that will add a bit of love to your day. We covered talking about outlines and iterations and learning, plus Grace Hopper's presentation on data, hardware, and software. As always, thanks for listening and happy coding.